Continuing with our graph examples, we see one that estimates the monthly population from January 1st to November 1st. Actually, there's probably another month there. Doesn't say what year. Oh, probably 2001. But there are several defects with this. The first bar is the resident population. I assume that means people who live on the continental U.S. The second bar is residential population and armed forces overseas. These would appear to be redundant in that the second bar includes the first one. If the user wanted to show a total, then the stacked bar would be appropriate. Do a calculation to figure out the armed forces population overseas and then stack it on the other one. I have no clue what civilian non-institutional population is. Something like that should have a note attached to it so that it could be explained. Okay, we have problems with scale with this graph. The author just simply took the first 5 states alphabetically and compared them. You really ought to have a reason for graphing, a statement you would like to make. Here the differences between 98 and 99 are minimal. You either need to choose states that had a notable difference or choose the states in one region. If we had compared Nebraska and Colorado, South Dakota, that would be meaningful. This graph is accurate, but when you see it, what question do you ask yourself? I asked, well, is it fair that Nebraska has only 3 representatives, huh? And there's a way to combine 2 different scales so that we could have graphed population behind the bars. Usually it's done with lines. Don't know why, but it is. Or maybe we could have just graphed the populations of the states that had 3 representatives, or 3, 4, and 5, so that we could compare. This graph is pretty good. You can see that Denver's population appeared to increase a little faster. But take a look at the legend on the right. What kind of looks not right? Let's see the next slide. Here, we fixed it again with the Control Enter, Shift Enter, Alt Enter, whatever in the legend to force April 1st to go to a second line and stay with the year. This is a nice graph. It invites you to compare in several different ways. Okay, who grew the most? Who grew? Who was second? Who grew faster than the other cities? Which ones were about the same? So this one is nicely done. This one has a big math error in it. The author of this graph told me outside of class that he was amazed to see that only around 10% of Nebraskans had a college education. That didn't feel right to me, but looking at his graph at first glance it seemed correct. 188,000 is just a little bit over 10% of 1,700,000. But where did he go wrong? Answer: the yellow population block includes everyone, including preschoolers, grade schoolers, high school, etc. So we're comparing college population to people who haven't had a chance to go to college. In addition, the high school block does not include the 18 to 25-year-olds who have graduated from high school. So we're missing 6 years of people who graduated from high school. So part of the data is from 2000, part of it's from 1990. I assume that the college population is included in all 3 blocks. If you're going to be doing a stacked bar, then all the pieces of data must be mutually exclusive. This chart used unlike scales, so it looks like in 2000 the population went down, doesn't it? But here we are, you can force the scale of a graph to be a certain number, and there we can compare them side by side. Personally, I think I would have combined them into one graph with different colors for the different years. This is a classic error. You should only use a line graph to indicate change over time. Years have to be in the x-axis. So here we are with lines. Well, this is like boring. There's really no point to this graph. It should have been a bar chart. Let's do that in the next slide. Okay, the blue bar is 97 to 98. The maroon bar is 98 to 99. And then the yellow bar is kind of an average of the two, 97 to 99. If you look at the chart, it looks like it goes up, then down, then up again, doesn't it? But there's really no point in doing an average of the two. What happens if we get rid of the average? All of a sudden, a very disturbing trend can be seen. What do you see from this graph? I assume this is a graph of median family income. If it is, family income in the Midwest states declined from 1997 to 1999. This revised graph is a, oh wow, look at that graph compared to the first one. And your point is, although if this were to illustrate a newspaper article, it would be a nice graph, but you can dress these up with a graphic figure. Use the state capitol building as a background or a big red N or something. You can also make the bars be parts of a graphic, which is very effective. We're going to break this segment here, and we'll return with the third piece, starting with some age comparisons.